I'm Brandon Lewis of Embedded Computing Design, and we're here at Sensors Expo / the Embedded Technologies Conference 2019 in San Jose. I'm with Colin McCracken of congatec. How you doing, Colin?
Doing well. How are you?
Doing very well. You too. So one of the big trends that's happening in industry is towards workload consolidation. A lot of people that's still a new term for them. So can you explain exactly what workload consolidation is?
Okay. Well, basically, in the old days, you used to have let's call it a user interface processor, and you'd have another one, let's say a PowerPC or an ARM, doing a real-time component. And these were separate systems within a big system.
Right. So with workload consolidation, I'm assuming that we're talking about moving all of those things into one system.
Absolutely, you got it. Yes. And in some cases, if you need to preserve the real-time component, then you would run, let's say, real-time systems type 1 hypervisor on, let's say, a 6-core Core i7 processor, and that way you get all of those tasks into the same, but you have protection. The real-time component is protected from hacking, from rebooting, from any other issues going on the other side.
And it's completely isolated, so that anything that's real-time, it wouldn't be affected by some perhaps other enterprise-type application that's running in another partition, correct?
Exactly right, and even from rogue attacks, hackers, security, a lot of those kinds of issues, the part that's exposed to the outside cannot get through to the real-time component.
Very good. And just for all the embedded developers out there who may not be familiar, a lot of people think about hypervisors and virtualization in a data center context, but when you said a type 1 hypervisor, you're not talking about a data center like a KVM hypervisor, right?
Yeah, so this is basically bare metal. So basically you can assign, let's say, 1 core to a real-time component and 4 cores to an application like, let's say, a camera that's doing facial recognition. And then the other thing about it is, unlike the data center, those are optimized for data throughput, and the embedded hypervisor is optimized for latency.
Oh, that's excellent. Okay, Colin, so can you explain a little bit about what's going on here?
Yes, absolutely. So behind the scenes here, we have a 6-core Core i7 processor, and 4 of the cores are allocated to this camera. This is a Basler camera right here. And it's running Ubuntu Linux. And as you can tell, the application is looking at the faces and making a determination of the mood. So you see anger, neutral, happy, and sad.
I didn't think I was mad.
Yeah, well, there you go. It cannot lie, right?
It's
intelligent software,
right?
Yeah. So, and then up front here, we have a pendulum. Now, this is something that is meant to represent a real-time application that's independent of the camera application. Notice here I can knock it, the pendulum, and it'll restore itself. Now, the cool thing here is to show the isolation, we could completely reboot the system with the Ubuntu Linux, and this will go away, and this will still keep running. So, in a real-world application, let's say this could be some autonomous vehicle or drone, you can have some of the flight critical or mission critical robotic arm or other type of application running here that's completely separate from something that's doing the maps or doing vision, image capture, database lookup, all these other types of things. So you can see this in machine vision, deep learning, other types of applications. So
that's great. And is there any specific type or brand of hypervisors that you're using here, or is it?
This is the real-time systems. This is a company in Germany. The folks who started this company came out of running actually x86 with some robotic arm applications. So traditionally, x86 wasn't as known for doing real-time applications. So they pioneered the way to do that. Now it's made available to all kinds of embedded applications.
That's great. Wow, that's some excellent stuff, Colin. Thank you so much for sharing that with us. Where can people go if they want to find out more about what congatec is doing with workload consolidation and maybe just about workload consolidation?
Okay, www.congatec.com, congatec.com.
That's very good.
Thank you, Brandon. Good to see you.
You too. Thanks, Colin.
Thank you.